This is lesson 67 on registers. Here's the block diagram for the edge-triggered D flip-flop that we talked about in the last few lessons. You remember that D and clock are the inputs, and Q0 and not Q0 could be the outputs. And on the rising edge of the clock, D goes to Q. That is, as Q0 gets whatever D is on the rising edge of the clock. Now, we'd like to be able to store a bit in Q sort of permanently, as in a register. The problem is that in real computer systems, any kind of processor, computers, we have a clock that's on all the time. So this clock is continually giving a rising edge, which means that every time there's a rising edge of the clock, whatever D is goes to Q0. So we want to be able to modify this so that we can store a single bit. Here's a circuit that will do it. This is a 1-bit register. We're going to introduce a load signal. That is, we have an input, I call it input 0, that we want to store in Q0 here. And we want to store it when the load is high. So the idea is we bring load high such that on the next rising edge of the clock, whatever is in input 0 goes to Q0. Then we can bring load back low, and we want the bit to stay here. So how does it work? Well, the idea is that we bring Q0 and we feed it back through this AND gate, and we AND it with not load. So when load is 0, not load is 1. If not load is 1, the input to this AND gate would be 1, which means that Q0 gets through. This OR gate, if load is 0, load signal goes into this AND gate, which means the output of this AND gate is going to be 0 no matter what input 0 is. So 0 ORed with, in this case, Q0 means that Q0 sits at D. So that on every rising edge of the clock, the bit that's already stored in Q0 just gets stored again, and so it just stays there. On the other hand, if load goes to 1, then we enable this AND gate, which means that input 0 shows up here. Not load will go to 0, it means there'll be a 0 here. So 0 or input 0 means that input 0 is sitting at D now, so that on the next rising edge of the clock, whatever bit input 0 is will get latched into Q0. Then when load goes back low, then whatever is in Q0 just stays there as it just keeps wrapping around. So this is a little circuit that would make a 1-bit register. We can write the logic equation for D. D is just going to be Q0 ANDed with not load, or input 0 ANDed with load. So here's the logic equation for D. Now, we can also represent this 1-bit register as a little block diagram with a load coming in, input 0 and clock as the inputs, Q0, not Q0 as the outputs, and we can have an asynchronous clear coming in. Then we can describe the behavior of this 1-bit register with just this if statement. If the rising edge of the clock, then if load is 1, we want Q0 to get input 0. And if load isn't 1, then this if statement isn't executed and nothing happens. That is, Q0 will just stay the same. So here is a way to describe the behavior of a 1-bit register. We can make a 4-bit register out of 4 1-bit registers by putting a common load signal to each one. So when load goes high, they all get loaded. In Q0 gets input 0, Q1 gets input 1, Q2 gets input 2, Q3 gets input 3, all in parallel. And we also have a common clock signal. So on the rising edge of the clock, all 4 inputs will get latched into all 4 outputs of this 4-bit register.